So hello everyone. Today we see some questions based on oxidation number. So we see some different examples today. Okay. So firstly, iron shows the lowest oxidation state in which of the following compounds? Okay. Okay. See the FeSO47H2O. So just before that, I want to give some examples. So to which we have to write the direct oxidation numbers. ఓకే కొన్ని క్యాలిక్యులేషన్స్ మనకి కొన్ని కాంపౌండ్స్కి మనకి డైరెక్ట్గా ఆక్సిడేషన్ నెంబర్ తీసుకుంటే ఇట్స్ బికమ్ సమ్ వాట్ ఈజీ టోటల్గా ఎగ్జాక్ట్ క్యాలిక్యులేట్ చేస్తే అదే వస్తుంది మనకి. ఫర్ ఎగ్జాంపుల్ SO4 ఉంటే ఆటోమేటిక్గా మనం పవర్ -2 తీసేసుకుంటాం. బికాస్ సల్ఫర్ ఫర్ ఎగ్జాంపుల్ సల్ఫర్ generally +6. Okay, oxygen -2, 4 into -2 -8, overall becomes -2. కాబట్టి సో మళ్ళీ సపరేట్ క్యాలిక్యులేట్ చేయకుండా జనరల్గా SO4కి -2 తీసుకుంటాం. నెక్స్ట్ సైనైడ్ ఇట్ హ్యాస్ Cn-. నెక్స్ట్ ఏంటంటే Cl-, Br-. సో అవి జనరల్ థింగ్స్. ఓకే, నెక్స్ట్ H2O కూడా 1 hydrogen carries +1 +2 O -2. So overall power 0 అవుతుంది. Next carbon monoxide also becomes 0. Okay, so next so nitrosonium. Okay, NO కొన్నిసార్లు NO పర్ఫెక్ట్గా 0 ఇస్తాడు మనకి, NO కొంచెం స్పెసిఫిక్గా NO+ ఇస్తాడు. సో in the oxalate C2O4 వచ్చిందంటే కంపల్సరీ హ్యావ్ టు టేక్ -2. నెక్స్ట్ S2O3 థయోసల్ఫేట్ వచ్చింది అనుకో, S2O3 -2. ఆల్రెడీ మనకి radicals, we know the positive radicals, negative radicals. ఆ నెగిటివ్ రాడికల్స్ అయాన్స్ నేమ్స్లో వచ్చింది మనకి. కాబట్టి డైరెక్ట్గా ఇవి అండర్స్టాండ్ ఆల్రెడీ యూ హ్యాడ్ యూ రిమెంబర్ దిస్ ఇన్ లాస్ట్ ఇయర్. థయోసల్ఫేట్, సో ఆక్సలేట్. If NO3 is there, that is also in the form of minus. NO2 is present, is also in the form of minus. So we'll get some more examples. So based on this calculator, the iron oxidation number in which compound iron is having least oxidation state. So we can iron calculate that. So it's having 4 problems. X. So SO4 simply we know the -2. The H2O just take it 0. Okay, 0. So X equal to 2. Here iron oxidation state is 2. That means ferrous. For this example take X. Carbon monoxide, that is 0. 5 into 0, nothing but 0. So here iron oxidation state is 0. What is this? So 0.94x. For oxygen, what is that? -2. Okay, oxide is that. So that is 0.94x equal to 2. The x equal to 2 by 0.94. Or we can write x equal to 200 by 94. Here that is 3x, it's -8. Okay, x equal to 8 by 3. So in which iron oxidation number is 0, sorry, least one. కొన్నిసార్లు మన నెగిటివ్ రావచ్చు, కాకపోతే జనరల్గా ఐరన్కి నెగిటివ్ వచ్చే ఛాన్స్ లేదు. బికాజ్ ఐరన్ ఈజ్ ద మెటల్ కాబట్టి ఆల్వేస్ ఇట్ డొనేట్స్ ఎలక్ట్రాన్స్, టేకింగ్ ఎలక్ట్రాన్స్ ఉండదు ఐరన్కి. సో పర్టికులర్ వాల్యూస్లో 200 by 94, 8 by 3 అంటే సో ద B is the answer in which iron is having 0 oxidation number. Okay. So next see some more examples. The oxidation state of iron in So Na4 FeCN taken to NOSO4. So here we have to find the oxidation number of iron. Okay, just do the calculation. That is a 4 sodium, that is 4 into 1, plus we have to find the iron, that is 1 iron, 2 cyanides. Already just now we written cyanide, Cn is having -1. So the 2 into -1 plus NO is even 0. So కొన్ని specific examples for NO plus ఉంటుంది. So NO plus ఉంటే they will mention on the above the NO. Okay, SO4 that is -2, overall charge 0. Then the square box type of compounds are known as complex compounds. Okay, so this is 4 plus x minus 2. Sorry, this is just wait. This is NO5, not 2. This is NO5. Sorry, CN5. It is given 5. So -5. So -7. This becomes +4. The oxidation number of iron is 3. So let's do one more calculation. So one more complex compound, that is Na2FeCN taken 5, nitrous sodium H2O. So again we have to calculate the oxidation number of iron. Okay, plus NO given +1, so +1. So hydrogen 0. Sorry, hydrogen means H2 was totally 0. 2 plus x minus 5. So here -5, the x equal finally we will get 2. Okay, means the iron condition is ferrous. Here iron condition is a ferric. Next and Cl minus ions converted to Cl2, the oxidation number of chlorine. So the oxidation number of chlorine, so changed from dash to dash. So simple, we know that here chloride ion means so we can write answer -1. It is changed to Cl2. Cl2 means it's a free state, so that is 0. -1 to 0. It is changed from -1 to 0. So let's see the other example. Okay, for FeCN taken 6. What are the iron oxidation states? here 4 into 1 plus x minus 1 overall 0. Okay, overall charge is 0. Here iron charge, so 3 into 1 x plus 6 into minus 1. Okay, here iron is in ferrous condition, here iron is in ferric condition. So maximum complex compounds flow metals was the iron, chromium, so like that. Let's see in C3O2. Okay, what is the carbon oxidation state? What is the carbon oxidation state in C3O2? Carbon suboxide. It's called carbon suboxide. So general calculation to them 3x minus 4 equal to 0. That is x equal to 4 by 3. So if you observe the all over if you observe the structure, so it is like this. Means the average oxidation number of a carbon is 4 by 3. But if you observe an individual atoms ki మనం find out చేస్తే what is the structure of C3O2 means it is like this. So this is C3O2. So here for overall calculation we got 4 by 3 oxidation number, but see what is the oxidation number of the individual carbon atom. This carbon is having oxidation number 0. So because this carbon is connected with the carbon and carbon only, means it is connected with same element, no gaining of electron, no losing of electrons, kabatti 0. This carbon is connected with the electronegative element. Electronegative elements general minus 2. So obviously this carbon will get plus 2. This carbon also will get plus 2. So total 3 carbons are there, total charge 4. So that's why each carbon is having averagely x is having 4 by 3. So original is plus 2, 0, plus 2. Okay. Let's see one more example. It's Br3O8. What is the oxidation number of bromine? Okay, and now first we do the normal calculation. Okay. Well, 16 by 3. Each bromine x equals 16 by 3 contribution. But how its position takes place? So Br3 all are connected like this. So this is Br3O8. Okay. So all oxygens are having minus 2, minus 2, minus 2. Total 8 oxygens. Minus 2 minus 16 is equals plus 16. But this bromine is having how many connections? 1, 2, 3, 4. 4 connection with oxygens. 2 oxygens to double one 4 connections. So e right side connection, left side connection into only with bromine. The same atoms తో ఉన్నప్పుడు no tendency to lose, no tendency to gain. అంటే సో ఈ బాండ్ తోని నో పాజిటివ్ నో నెగిటివ్, ఈ బాండ్ తోని నో పాజిటివ్ నో నెగిటివ్. సో ఇక్కడ దిస్ ఆక్సిజన్ మోర్ ఎలక్ట్రోనెగటివ్ కాబట్టి సో ఇక్కడ ఆక్సిజన్స్కి ఎన్ని బాండ్స్ ఉన్నాయి టోటల్గా? డబుల్ బాండ్ టోటల్ 4 బాండ్స్. సో అంటే 4 బాండ్స్ అంటే ఇక్కడ ఇట్ విల్ గెట్ ప్లస్ 4. సో ఆక్సిజన్ విల్ గెట్ జనరల్లీ -2 ఇట్ ఈస్ ప్లస్ 4. And whatever this so this bromine ki left side bond, so it's same bromine to kabatti no losing no gaining, so remaining 6. So oxygens -2 and -6 and bromine will get +6 with +4. So ikkada bromine kuda +6. That's 1 2 3 4 5 6. See bond enduku count cheyatledu ante between the same atoms ko no gaining no losing kabatti dan connect cheyatledu. 6 6 12 4, 16. 16 total charge. For 3 atoms, this becomes 16 by 3. Okay. Next, S4O6 minus 2. What is the sulfur? Okay. So, what is the sulfur charge? 4x minus 2 equal to minus 2 to 2.5. So, but then again, mentioned sulfur is having like this 4O6. Okay, that is O. So, sulfurs, 4 sulfurs are present. This is a S4O6 minus 2. So, minus 2 means overall charge minus 2. So, I can mark so the overall charge minus 2. So, normal calculation we got like this. So, its structure is like this. So, this carbons is plus 6 plus 6, 12. Let's wait. So, this sulfur having 0. So, as they are connected with only sulfur atoms, 0. So, this is connected with 1, 2, 3, 4. So, actually, this is O5. O minus charge. This is also minus charge. So, this sulfur is connected with how many bonds? 5 bonds. 5 bonds. 1, 2, 3, 4, 5 bonds. So, E sulfur countless because sulfur to sulfur linkage not makes any change. So, this is plus 5. So, this was also plus 5. Okay. So, here are 2 oxygens, 2 bonds, 1, 2, 3, 4. This is minus 1. So, already minus 2, but it is having only minus 1 charge. But taking total 5 only. Total become total positive charge 10. 10 for 4 sulfurs. 10 for 4 sulfurs and that is for 10 by 4, that is equal to 2.5. The average that is having a 2.5 oxidation number, but oxidation state of each sulfur is plus 5, 0, 0, plus 5. Okay. So next. Next is a very important one, that is HCN. Hydrogen cyanide, what is the oxidation number of carbon? What is the oxidation number of carbon? So the hydrogen 1, so plus X. So nitrogen we take minus 3. So that X equals becomes 2. So here that's important thing is we have to follow the basic rule for this. So actually manaki nitrogen, E carbon lo koddi confusion. So దాన్ని ఎలా మనం ఓవర్కమ్ చేస్తామంటే యాక్చువల్గా there is a triple bond is present between the carbon and nitrogen. There is a triple bond is present. So ఈ carbon and nitrogen triple bond లో so ఇక్కడ carbon, nitrogen, carbon, hydrogen obviously plus 1, no doubt in it. Next X. So nitrogen ఎట్లా క్యారీ చేయాలంటే nitrogen is more electronegative than carbon. కాబట్టి nitrogen will get negative charge. So 3 bonds ఉన్నాయి, 3 covalent bonds ఉన్నాయి కాబట్టి 3 negative charge తీసుకోవాలి. Okay. So minus 3. So therefore X equal carbon becomes 2. So next, let's wait. So next question is the oxidation numbers of the oxidation numbers of iodine and chlorine in iodine trichloride are dash. Okay. So I see here. So each iodine having, so which is more electronegative? Actually both are electronegative elements, but which is more electronegative? Cl is more electronegative, so that's why iodine will get so positive. So what is the iodine charge? Here we will get so Cl takes electron 3. This means what is the iodine charge is 3 and Cl oxidation number is, oxidation state is -1. Okay, so it is -3 and 1. Okay, see next one, FeS44. So calculate the oxidation state of iron. So just take one iron X. We know that SO4 minus generally carries SO4 minus 2. So ammonium. So here also remember, ammonium is always +1. So overall ammonium +1. How many ammoniums are there? 2 ammoniums are there. Okay, 2 into 1. Again SO4. SO4 means it is -2. -2. Water is 0. Overall charge, that is 0. That is first will also get cancelled. When here iron is having ferrous position, so iron has only 2 choices. Unte 0 ante carbon monoxide లేకపోతే ఫ్రీ ఫామ్లో ఉన్నప్పుడు, కొన్నిసార్లు ఫెర్రస్ ఫెరిక్, ఓన్లీ 2 చాయిసెస్, +2 and +3. So next and we completed that. H2HgI4. It's called Nessler's reagent. It is known as Nessler's reagent. It's a useful reagent in laboratories to know the ammonium ion. So ammonium ion ki, so testing ammonium ion ki testing purpose lo we used a Nessler's reagent. Okay, its formula is Na2HgI4. So we have to have mercury liquid metal. We have to find the oxidation number of mercury. X plus 4 into -1. So here Hg is present in the form of, in terms of +2. But actually the mercury ki 2 choices unte, Hg⁻+1, Hg⁻+2, mercurous, mercuric. Here mercury is present in the form of mercuric, that is Hg+2. See some more examples. Okay, that is BaO2. So oxidation number of oxygen. So oxidation number of oxygen, simply we know it's barium peroxide. So barium, it is fixed. Okay, there is a second, as it belongs to second A group, it is a fixed 2. So plus 2x. So x equal -1. So oxygen oxidation state -1 ఉందంటే nothing but it's barium peroxide. Okay, what is it? If you see the structure of barium peroxide, so peroxide means oxygen oxygen linkage. Here barium present in the form of +2, O minus 1, O minus 1. Okay, O bond is called, we know that it is called peroxy bond. Let's see the sodium peroxide. So what is the sodium peroxide? Na2. What is the oxygen oxidation number? So that is a 2 into 1 plus 2x equals 0. So x equal -1. Oxygen oxidation number -1. So -1 వస్తుంది కంపల్సరీ దిస్ పెరాక్సైడ్స్ లోనే -1 వస్తుంది. Means Na2O2 is called sodium peroxide. So what is the structure of sodium peroxide? O linkage ఉండాలి మనకి NaO. Just like one hydrogen peroxide is also like this, hydrogen peroxide. So we are not giving actual shape, just we are giving the bondings. Okay, bondings. Actually the hydrogen peroxide original structure అయితే this opaque book structure అంట. ఈ 2 ఆక్సిజన్స్ పెరాక్సీ బాండ్ మన బుక్ ఓపెన్ చేసినప్పుడు మిడిల్లో ఉంటుంది. సో ఇది 1 డైరెక్షన్లో ఉంటే ఇది 1 డైరెక్షన్, ఇది 1 పేజ్ డైరెక్షన్లో, ఇది 1 పేజ్ డైరెక్షన్లో ఉంటుంది. బట్ ఓన్లీ బాండ్ని డిస్కస్ చేస్తున్నాం కాబట్టి ఇక్కడ ఓ బాండ్ కూడా డిస్కస్ చేయడానికి సో వీ రిటర్న్ స్ట్రైట్ వన్, దట్ ఈస్ ఓస్ ఆర్ హ్యావింగ్ -1 -1 +1 +1. So -1 -1 +1 +1. So overall becomes neutral. So these are the different examples of oxidation number. Okay.